Okay, I want to get on to part 2. As I said, I was going to focus mainly on part 1 and 2. This is the meat of the concept of this experiment. As I said, the reference blank test is something that's going to carry over. But in terms of the concepts for this experiment, this is it, 2A. All right? You're really going to know and understand the results. That's why all of you are doing it. So can we predict the solubility of an ionic compound based on the position of the cations element in the periodic table versus the likelihood that if it's not very soluble, it's going to come out of solution? So you formulate your hypotheses and predictions based on the periodic table and the model that we just talked about, okay? That we need a polar solvent, like water, to reduce the effective charge of the ions, to get the ions to dissociate and exchange partners. And the ions are held in because the water can, in solution, because the water can insulate them. So for example, on your pre-lab, some students are having problems because it asks you to compare different salts and their solubility based on the literature values. Okay, so for example, let us compare NaF and MgF2. The main difference between these two compounds are just the cations. They both have the same anion. Okay? They're both electrically neutral. If you look at Na+, Na is +1, Mg is +2. So you might say, okay, well, the difference between these is simply one has a +1 charge and the Mg has a +2 charge. Maybe it would be harder to insulate a +2 charge. Then you also got to look at the size because they're in two different families. Okay? Does size matter? And then other example, including BAF2. Now these are in the same family. Mg is 2+, Ba is 2+, but Mg is smaller. So when you would look up the solubility of these two compounds, you could then see if one is more soluble than the other. If there is a difference, then we can look at size, okay? Size impacts. Again, I'm not giving results here. I'm just telling you what you might be thinking about. Make sure you get the data and look at that. Here's the experiment itself and how you're going to do it. This is a table on page 27 in your lab manual. Looks like this. Each team is assigned to certain cations. For example, teams 1, 2, and 3 are assigned to mercury 2+ cation, except you're not going to be given that particular cation because of toxicity concerns, so we're reducing the amount of exposure to it. Okay? But you would take that particular cation, and it will be OLF in the form of a nitrate salt. And you take a dropping pipette, and you put a drop of it in each column of the table. You say, oh, wait a minute, how are we going to do that? Well, Ed's holding a dropping pipette, and you don't put it on the paper. You put a transparency sheet on top of the table, and you put the drop on top of the transparency sheet, okay? And you don't make your drops too big so they flow into one another. Just a little bitty drop into each cell, okay? Now we're going to see how many times it precipitates and compare the number of times it precipitates with other cations. You have 6 precipitating agents. Indeed, you're going to find mercury will precipitate with 5 of the 6. It tends to be pretty insoluble, okay? So all the precipitating agents are sodium salts. Sodium ions are very soluble. However, the anions are not. So we get some sodium chloride, okay? Add sodium chromate, iodide, oxalate, sulfide, sulfate, okay? you record how many times it precipitates, and if the precipitate is white or a color other than white, please note that any precipitate that is white is colorless in solution. Just like table salt that's white becomes colorless in solution, anything that has a color other than white as a solid itself will have a color.